Alright, this is for Unit 1, Activity 5, Makeup. Alright, so what we are doing here, and you can kind of see from the picture, we have a closed loop set up with two bulbs, and we're going to be using a compass to measure some things that occur as the loop is closed. Alright, so what we're going to be looking out for is the compass to deflect. Alright, so the deflection will determine the electrical strength. Alright, so how much it deflects, we want to predict or determine, if it'll deflect more in one wire versus another. The first wire that we test, we're just going to designate as A. Alright, so that's actually going to be this disconnected wire over here. Alright, so the wire by the springs on the battery pack. Alright, and you also need to predict the direction and amount of compass deflection. Alright, so we're going to determine if it moves to the right, to the left, more or less, that sort of thing. And then finally, we are also going to flip the battery pack. So if you notice, your observations have a set of information for the original battery pack positioning and then after we flip it. Alright, so what I want you to do is just to make your predictions a little more similar to your observations, is just write this table in. Alright, and then original is as the battery pack is set up now. So predict what direction the compass will deflect. Alright, and what that means is if you notice right now, the white tip is pointing towards the battery pack, and you'll be able to see whether or not it moves towards the right or towards the left. Alright? And then also predict the amount. So like as we go through the other wires. So this red wire is A, this one's B, and then that one over here, the second red one, is C. Okay? So predict direction and amount of deflection for all three wires for the current battery pack situation and then for when we reverse it, which means we'll take the battery pack and say this cord right now is connected to the springs. The next time when we flip the battery pack, it'll be connected at this end, and this cord will be connected to the springs. Alright? So go ahead and pause this, get your predictions down, and then turn it back on to actually see what happens. Alright, so this wire here is going to always be the one that we measure first. Alright, so it's the red wire, currently it's the red wire attached to the springs, and this wire will always stay wire A. Alright, so we do have a functioning circuit, but before I test, before I put the wire over the compass, I'm going to disconnect it so that we can tell exactly what sort of change happens. Alright? So here is the wire over the compass. Give myself a little more slack so I can get it connected. Alright, and lining it up right straight across. And then that's with it connected. Let's see. Alright. So you notice that it does deflect to, and if the bulbs get screwed up, it does kind of fluctuate a little bit, but it did move to your left. Alright, and then what I would do is I would just kind of consider this amount to be normal. Alright, and then if you notice that there is a big change, like a significant difference from this amount, then you could say that it's less or more. Okay, so that was wire A for the original setup. Now we're going to, in order to be consistent and controlled about our measurement, we always want to measure the wires in the same direction. So if we think of the spring as being start, we have the end of the wire closer to the spring up top on the compass. So we want to make sure we maintain that for all of the other wires. So like for this black wire, we want this end that's closer to the springs up top. Alright, so in order to do that, you can't really rotate the compass at all. It always points in the same direction. So we're going to rotate our system around so that that is possible. Okay, so now the black wire is set up so that I have the end closer to the springs. Alright, the end closer to the springs actually going across the top of the compass. Alright, so now I'm going to close the connection, and you can see again it goes to the left. And sorry, I keep letting go. Then indicate whether or not you think that's a significant amount more of deflection, or about the same, or significantly less. Alright? So, I'm going to to rotate it again to get that last wire. Alright, because again, this end is closer, so this end, if you follow through the path, is going to be closer to the springs. If I get the battery pack too close, it does actually make the compass deflect. So I want to make sure that's away, but this end was closer to the spring, and the other end is closer to the hook, the little, I guess, knob on the battery pack. So I want to make sure this end is at the top. Alright, and then I'm going to get it going, and there's your deflection. Alright, so in the same direction again, and indicate whether or not you think that's significantly more, significantly less, or just about the same amount of deflection. Okay? Alright, so now let's go back to the beginning. Alright, we're going to test our wires the exact same way. It's just now our battery pack is going to be flipped. Alright, so if you notice, before this wire was on the springs, now it's going to be on the hook, or the little knob, and this wire will be on the springs. So now when we set up our wires, they have to be closer to the hook. So that way we test our wires the exact same way as last time. The only difference in our testing is the fact that the battery pack is flipped. So get this guy hooked up. So there it is over the compass, and now I am connecting it. And you can see that now it's moving to the left. And then indicate if that was the same amount of deflection, a significantly increased amount, or a significantly decreased amount as compared to what you were seeing before. Okay? And rotate so that we can do the same thing that we did last time. So here's the black wire. Sorry, lost my connection. Now it's connected. You can see again, went to your right, and then indicate if that's the same amount of deflection, significantly more, significantly less. Okay? And the last thing, disconnect this, is our third wire. We're rotating, and we have it set up. Keep my hands out of here. And now it's connected. Again, one to the left. Indicate if that was a significantly greater amount of deflection, significantly less, or the same amount. Alright? So your conclusion, you should make some judgments about, say, the direction of the compass deflection based on the direction of the battery pack, or how much compass deflection based on which wire it's in. Alright? One thing that I will give you is, aside from maybe the very, very first one that we did, those compass deflections really were not all that different from each other. Alright? So I don't know if this will actually show you something, but... Oh, you know what? Haha. That doesn't work because it's not in the same direction. There, I guess, I'm not going to show you something right now, but we will get into this. There are other things that do actually create a giant change in compass deflection. So this was not significant enough to say they were each different. But, so come back with a conclusion written in and be able to answer some questions, and I'll give you the consensus in class.